All right, this is note card 4, and the title is Limits and Asymptotes. So let's see what Stacy says. She says a horizontal line, y equals b, is a horizontal asymptote, or we can abbreviate that HA, if one or both of the following limits exist. So if you look at a function and you look at what happens as x goes towards infinity, or, I should say and or, as x approaches negative infinity, if it approaches a number, then the line y equals b would be the horizontal asymptote. And in the next note card, we'll find analytical strategies. Okay, and these analytical strategies we're going to look at is called Betsy, Bobo, and Botu, but that's going to be in the next note card. Okay, and a vertical line, x equals L, that's going to be a vertical asymptote, or a VA, if, as x approaches a number from the right, if it goes to positive infinity or negative infinity, or as you approach that number from the left, if it approaches positive or negative infinity, we would call that a vertical asymptote. Now, how do you find vertical asymptotes analytically? Okay, it tells us factor the rational function to find any removable discontinuities, cancel the common factors, then set the remaining denominator equal to 0, and the VA is x equals that number. Okay. So let's see what it asks us to do here. It says for numbers 1 through 4 below, graph and or use the table on your calculator to find the limit of the function as x approaches positive infinity, as x approaches negative infinity, and the equations of any horizontal asymptotes and the equations of any vertical asymptotes. So we're going to use our calculator to help us out here to start to understand this. Okay, so let's look at number 1 here. So I'm just going to go ahead and put this function into my calculator. All right, let me zoom in a little bit. Okay, so I set up a fraction. 2x cubed minus 9x squared plus 4x all over negative 3x cubed plus 6x squared plus 24x. And since I don't know what this graph is going to look like, I'm just going to hit, to start with, I'm just going to go a standard 10 by 10 window. So zoom number 6 or zoom standard. Okay, so that's a rational function. Okay, rational because this is a fraction. And let's try to kind of look at some of this. So as I go further and further out, as I go towards positive infinity, it looks like this graph is kind of leveling out. We're getting kind of horizontal at some number or some value just underneath the x-axis. Okay? And as I go towards the left, towards negative infinity, it kind of looks like it's leveling out again. Now, my goal in parts A and B is to figure out, well, what value is it approaching as I go towards positive infinity and negative infinity. So let's start by doing part A there. All right. So if I just hit trace, as I move my cursor, as I go further and further out, okay, I'm looking at these y values, negative 0.49, okay, all of these. We go further and further out. Now this could take a long time to get all the way out closer and closer to infinity. So a quicker way to do this is let's use the table in our calculator. So I'm going to go second table set. Now where should I start my table? I care about as I approach infinity, which is a really big number. Okay, so maybe let's start at something crazy like 1,000. And maybe I want to do my change in table equal to another 1,000. Now let's actually look at the table. So I hit second graph. Okay, so as I go further and further out, Okay, I'm getting really big x values. What do you notice about all these y values? Okay, it looks like they're all about negative 0.667. Okay, now they round it when I actually look in the table, but if I hover over that, it's negative 0.666597. So as I keep going down, it looks like the changes in it get really, really small. You're out to like the the fifth or sixth decimal place. The changes are really small. Now, what is this approximately? It's about negative 0.6 repeating, if you think about it. Okay, and what is negative 0.6 repeating? Well, if you know your rules, okay, so we got negative 0.6 repeating, okay, that's going to be negative 2/3. So the further I go out to the right, the y values get closer and closer and closer to negative 2/3. Now let's go back to the graph here. So that was part A. What happens as I approach negative infinity? That means as I go further and further and further to the left. Now I'm going to be talking about this part of the graph as I go further and further and further to the left. Okay, so let's do the kind of the same thing. Maybe we start our table at negative 1,000, but then we want it to go down by 1,000 each time. And again, second graph. What do you notice here? The more you go down, it looks like these y values that it's approaching are all the same thing, negative 0.6 repeating. It gets closer and closer and closer to that. So that's the same number, negative 0.6 repeating, which is, again, negative 2/3. So here's the idea. Let me just put in another line, the line negative 2/3, y equals negative 2/3. If I go ahead and hit graph now, do you see that red line that's in the graph here? This blue curve is getting really close to the red line, but it's never quite touching it to the left and also to the right. Okay, so I go further to the right, the blue line is getting really close to the red line, but it doesn't quite ever touch it. It looks like it might, but it actually doesn't. Okay, so that's why these limits, as I go towards positive infinity and towards negative infinity, are both negative 2/3. It's not really a surprise. Look at that coefficient right there. That might be a way. So that imaginary horizontal line here in red is the horizontal asymptote. Okay, so that's part C. Okay, the equation of the horizontal line that the graph approaches, since it's a horizontal line, it's y equals, and we said it was negative 2/3. That's the line that gets approached. Now, let's look at how do we do part D? How do we find the equations of any vertical asymptotes? So in here, if you kind of look at the graph, it looks like as I'm getting close to a certain x value, I don't know what it is yet, but it looks like I could draw a vertical line straight down that this curve approaches but never quite crosses. Now I don't know exactly what that number is. Okay, so I mean I could take a guess. Okay, maybe about right. Maybe about right there, maybe at -2. Okay, but I'm not sure on that. It looks like I could draw a vertical line at about -2 that the curve would never cross. Okay, if I actually hit trace, okay, Here, when I'm at an x value of negative 1.96, the y value is 54. What about if I go to negative 1.99? Okay, it goes up to 166. So it's going up towards infinity from this side. As I come in from the other side, it looks like it's going down towards negative infinity. What about if I type in negative 2.01? Okay, it gives me this fraction, negative 502 divided by 3. Okay. So there's an analytical way to find the vertical asymptote. So here's what you're going to do. You're going to do some factoring. So if I think about this function, look at the numerator. You could take an x out of all three terms. So we could factor out an x. And if I do that, I would get 2x squared minus 9x plus 4. Okay. And you could further factor that. Okay. You could factor the quadratic there. You could get a 2x minus 1 times an x minus 4. Okay. Do a quick FOIL, 2x squared, that works. Negative 1 times negative 4 is positive 4. And if you do inners and outers, negative 1x, negative 8x, combine them, you get negative 9x. So that's the right way to factor that. Now what about the denominator? Look at all three of these terms. Okay. Look at all three of those terms. You could actually take out a 3x there. If I take out a 3x, or actually let's take out a negative 3x, we would be left with an x squared minus a 2x minus an 8. Okay. And that can be factored some more as well. That can be factored into an x minus 4 and an x plus 2. Now I'm scratching these out because I've simplified them further. Now the question is, well, what can you simplify? Okay, what can you simplify? Well, you see an x there and an x there. Those will cross out. You see an x minus 4 here, so they cancel each other out. Now the question is, what's left in the denominator? You see an x plus 2 here. What number can you plug in for x to make this whole thing 0? Hopefully you can say, well, that would be negative 2. If I plug in negative 2 right there, then this denominator becomes 0. So that's why the vertical line, x equals negative 2, is the vertical asymptote. Because when I plug in negative 2 there, negative 2 plus 2 is 0. And the way you can confirm that, if you hit trace, and then you type in negative 2, it shouldn't give you a y value. It should be blank, because that's the location of the vertical asymptote. There's an understood vertical line. You can actually draw in a vertical line real quick. If you hit second program, okay, if you go down to vertical, number 4, you can move this to negative 2. Oops. I'm trying to remember how to do this. Okay, I think I remember how to do it now. So here was the graph, just kind of going back. So I'm thinking that there's an imaginary vertical line. So I think this graph gets really close to an x value of negative 2, but it never touches it. So the way I'm going to draw a vertical line here, go ahead and quit out of there. So how did I quit? I hit second mode. Okay, let me quit out of there. And I'm going to go to second program because the word draw is above that. And I'm going to go to vertical. And I'm just going to type in -2 and hit enter. And hopefully you see when you do that, it draws in a vertical line for you. To me, it looks like this curve comes really close to this vertical line, but never touches it as I'm coming in from the left. And it looks like it gets really close to the vertical line as I'm coming in from the right. So that's the reason that the equation of this line is x equals -2, the vertical line, and that's why it's a vertical asymptote. And again, the analytical way I did that, I factored both the numerator and denominator, canceled out things that I could, and whatever remains in the denominator, I asked myself what question, what value of x could I plug in to make this parenthesis equal 0? Okay. So let's try number 2. So I'm going to clear this. I'm going to make a fraction. So square root 4x squared minus x minus 5 all over 4x minus 6. And again, I don't know what it's going to look like, so I'm going to start with a 10 by 10 window, so zoom standard. All right, this one looks a little bit weird. So let's try to do part A. What happens, this graph, the further I get out towards positive infinity? It looks like there's, to me, oops, it's hard to see. All right, so it looks like as I go further to the right, this is getting more straight, and it looks like it's approaching a certain number. My goal is to figure out what that number is. All right, so the easy way to do it is to go under your table, maybe start at 1,000, maybe go up every time by 1,000, and then hit second graph. Okay. So to me, it looks like these numbers are getting really close to 0.5 the further I go out. Okay. The further I go out, looks like it's getting close to 0.5. And we should know that 0.5 is the same thing as 5/10. That's how we would say it, which would be about a half. Now what about, let's go back to the graph, what about as you go to the left? Okay, as you go towards negative infinity along the x-axis. So now maybe we start at negative 1,000 and we go down by 1,000 each time. Okay. So the further I go to the left, again, it looks like we're getting really close to, well, this time it looks like negative 1/2. So part B, this would be negative 1/2 or negative 5/10. Okay. And it's possible for a graph to have two horizontal asymptotes. Okay, so let me go ahead and just put them both on here. So I'll put in 1/2 and I'll put in negative 1/2. And then we'll graph it and we'll make sure. Okay, so as I go to the right, it looks like the red line is being approached, and as I go towards the left, it looks like the curve is approaching the black line. So there's two horizontal asymptotes here. So in part C, the equations of any HA's, okay, so it could be more than one. So y equals positive 1/2 and y equals negative 1/2. Right. Now what about vertical asymptotes? And what about vertical asymptotes? Well, if we try to do some factoring here, okay, to get a 4x squared, we could have a 4x there, and we could have a x there. And to get a negative 5, we could have a negative 5 there and a positive 1 there. So that's going to be the correct factoring. 4x squared works. Negative 5 times 1 is negative 5. And inners, that's negative 5. That's positive 4x. You combine them, it's negative 1x. So that doesn't really do anything. I can't pull anything out of the radical. In this one, I could factor out a 2, and I could get a 2x minus 3. Okay, so nothing's going to cancel, so that's not going to help us. But now, let's set this thing right here in the parenthesis, this 2x minus 3 equal to 0. And then let's solve it. Let's add 3 to both sides, and then let's divide by 2. So x equals 3/2, or x equals 1.5. If x equaled 1.5, the whole denominator would be 0. Okay? So that actually lets us figure out, let's make sure, if I go to my graph here, let me go ahead and get rid of these horizontal asymptotes. Okay. Now, if I type in 1.5, a way I can kind of see if I'm on the right track, if I hit enter, it should not give me a y value. Because if I plug in 1.5 here, it would make the denominator 0. So I'm going to hit enter, and that's good. That's good news. Okay, it doesn't give me a y value. All right. So now let's just make sure. Let's go ahead and draw a vertical line at 1.5 and hit enter. To me, that looks like it's approaching it. Okay, it's getting really close to that vertical line that was just drawn in for us. Okay, but we don't quite hit it, which is good. Okay, so that is the vertical asymptote. That's the equation of that vertical line. So in part D, you can write it one of two ways. You can either say x equals 3/2 or 1.5. They're both equivalent. So hopefully you're catching the hang of this. Let's try number 3. So number 3, 5 minus 9x. Oops, I need to set up a fraction. 5 minus 9x over 8x cubed plus 1. Again, start with a zoom standard. Okay, something a little bit different happens, but that's okay. All right. So here, if we just kind of want to think about horizontal asymptotes, if I hit trace, okay, as I go further and further and further to the right, what's the y value getting really close to? So all of these y values to me look like they're getting really close to 0, but not going over it. Okay. Now, even though it crosses 0 there, that doesn't really matter because we just want to think about what's happening at the end. What about on the left? Okay. The further I go out to the left, all these y values are getting really close to 0. So my first thought is that the horizontal asymptote is just y equals 0. And if I actually put that in here, y equals 0, and hit graph, yeah, they look pretty close to each other. That's what it looks like. Can I confirm it on a table? Sure. We'll start at 1,000 and go up by 1,000 and look at the table. So what's happening here? Let me turn this the second one off here real quick. Okay. Now they give me all these answers in scientific notation. Just think about when it says like e negative 8. That means move the decimal point 8 spots to the left. Okay. These values are getting smaller and smaller and smaller, but they're all really close to 0. Okay. So that's the important point. So A, it's simply 0. Now what happens as you approach negative infinity? Well, in our table, Start at negative 1,000. You can even start at negative 100,000. It doesn't matter. And then go down by 1,000 every time. What are all these numbers? They're really small numbers. They're all really close to 0. And they're just written in scientific notation for us. If you have a hard time with that, just change your table. Maybe you start at, negative 10 and go down by 1 every time. Okay. Again, look at all these numbers. Look at all these decimals. They're getting closer and closer and closer to 0. Right. So, what's the equation of the horizontal line that the curve approaches as you go towards positive infinity and or negative infinity? It's just y equals 0. Now let's go back to the graph. On this one, does it look like there's a vertical line, a vertical asymptote? So as I get really close to a certain x value, does it look like the curve is approaching infinity or going down towards negative infinity? Yeah, to me it looks like it's some number between 0 and negative 1. Okay, it's not quite 0, but it's also not quite negative 1. It's probably some fraction in between there. So how do you do that? Well, what you do here is you try to do some factoring. All right, now you can't do anything with the top. The numerator stays as 5 minus 9x. But this is the sum of 2 cubes. Okay, so here, how do I get 8x cubed? It's 2x times 2x times 2x. How do I get 1? It's 1 times 1 times 1. So that's actually going to factor into 2x plus 1 times, okay, if you remember your rule, okay, if you have, let me just write the rule here. If it's a cubed plus b cubed, that's going to factor into a plus b times a squared minus ab plus b squared. That's the rule for the sum of cubes. So the a is 2x and the b is 1. That's the a and the b. Now here it says a squared, so I'd have to do 2x times another 2x, which would be 4x squared, minus a times b. 2x times 1 is 2x. And since b is 1, b squared would be 1 times 1 or 1. Okay. Now this part can't be factored anymore. It never can. So what would make this thing 0? So take 2x plus 1, set it equal to 0, and solve it for x. So subtract 1 from both sides, and then divide by 2. Okay. So this right here is the equation of the vertical asymptote. That's what value would make this parenthesis equal to 0. So part D, the vertical asymptote falls at negative 1/2. And from the graph, that looks appropriate. Okay. If I draw in here, let me change this color real quick so it's easier to see. Okay. If I draw in a vertical line at negative 1/2, okay, so here's the curve. That looks appropriate. That blue line that got drawn in there looks appropriate. Looks like I'm getting the red curve is getting really close to that vertical line. Okay, so it goes up towards infinity, and it goes down towards negative infinity. It gets really close to this vertical line, but doesn't quite touch it. So that's the right equation of that vertical line. I'll try one more here. So here I have natural log, oops, so fraction, using a shortcut, natural log of x plus 2 over the exponential function 6 raised to the x power. Again, I don't know what it looks like to start with, so I'm just going to go zoom standard. Okay. So it's really hard to see here. It kind of does a little loop at the beginning. First off, you can't get a value smaller than 0. That's important. Okay. Like you can't take natural logs of negative numbers. That's why there's nothing to the left over here. Okay. So let's just kind of change our window so we can see it a little bit more clearly. So I'm just going to change my y min to -2 and my y max to 2. So it does one of these things. Okay. So it looks, as I go out towards infinity, as I go out towards positive infinity, it's staying really close to the x-axis. That's a y value of 0, right? So if you trace, you get all these y values, and they never cross the x-axis, but they're getting really tiny. Okay, smaller and smaller in scientific notation. Okay. Or if you go to your table, maybe start at 1,000 and go up by 1,000 each time. Okay. And that's actually giving me an error here because the numbers are getting too big for the calculator. So maybe we might want to start at 10 and go up by 1. Maybe that might work. Look at all these values, really small. Okay, look how small the decimal would become. Move that decimal 15 places to the left. It basically becomes a number very close to 0. So as I go out towards positive infinity looking at this graph, the y values approach 0. Okay. Now what about part B? What happens as I approach negative infinity? Well, there's no part of the graph over here. Okay, so the limit as I approach negative infinity, the limit doesn't exist because the curve doesn't exist over there. So part B does not exist. Now, is there an equation of a horizontal asymptote? Yes, there is, because I can draw in a line. Let me turn it into a green curve or a green line. I'm going to change my window just a little bit here. So there's the curve. And that curve looks like it's getting really close to that green line. And it won't ever quite touch it, but it'll get really close to it. So the equation of the horizontal line, the horizontal asymptote, is y equals 0. And lastly, for the vertical asymptote, we focus in there, can't do any factoring. We have to set that equal to 0 and solve it. Okay, well, ask yourself a question. It doesn't really matter if you plug in 0 for x, it wouldn't equal 0. It would actually equal 1 because 6 to the 0 equals 1. This thing actually will never equal 0. It will never equal 0. And because it never equals 0, guess what? There's no vertical asymptote. Or in short, there's no VA. There's no VA. That thing will never equal 0. The bottom will never equal 0. 6 raised to the x never equals 0. And it doesn't look like there's one either. It doesn't look like there's an imaginary vertical line that the curve gets close to but never quite touches. Because it never goes up towards infinity. The curve never goes up towards infinity, and it never goes down towards negative infinity. That's why there's no VA from a graphical perspective. So this note card wasn't very long, just 4 examples. Okay, but on the packet here, you're going to do the same thing. It's asking you to find the vertical asymptotes, the horizontal asymptotes, and the limit as x approaches infinity. So you're going to do it the same way, and they give you different functions. You can do it exactly the same way. All right, for problems 1 through 4. And in problem 5, it just says use the table below to find the limit of this function. Okay, so here's the x values. All right, and here's the y values. Okay. So what's the limit as x approaches 9? They give it to you in a table. So as you're coming in from the left, what are these values getting close to? And as you're coming in from the right, what are these values all getting close to? Hopefully, it's real quick, you can see that it's 6. Hopefully you can see that it's 6. Then we have a few more examples of piecewise functions. Okay. Remember, a limit is what it approaches, not necessarily what it equals. So number 6, it's just like you can imagine that's not there. Okay. Now this one, the limit as x approaches 1, figure out what the left limit is using that curve. Figure out what the right limit is using that curve. And as long as the numbers equal each other when you plug in 1 to both of those, then that's what you'll put there. And then there's a few more problems at the bottom. So just give those a shot tonight and let me know if you have any questions.